Welcome to my reality, a world where I try not to cry as I make games. My dream game, a game worth Borderlands 2, but mine, not just Borderlands 2, start with four characters that are mine, and then in the next game it's six characters that are my friends. Instead of little baby games that are just like mechanics of the abilities, we will get through it. So yeah, today we're just gonna finish up the um, geometry and actors and geometry, whichever order it goes through on, and we'll try not to cry. Reference for the different kinds of volume actors in Unreal Engine. Volumes are three-dimensional actors that change the behavior and characteristics of the area they cover in a level. Volumes are support actors generally used to detect when certain actor types have entered a specific area, trigger something in response. Volumes sometimes have built-in effects of their own, either in code or blueprints. You can use volumes to implement effects and behaviors like causing damage to the player or other actors inside the volume, blocking certain actors from entering the volume, acting as a collision surface, changing something in the environment, for example, opening a door when an actor enters the volume, changing the lighting or the visibility in a level, placing volumes. Place volumes in a level in the same way you place any other actor. In the main toolbar, click the Create button, click the Volumes category, then drag the volume you want to place to the level viewport. For more information, see Placing Actors. After you place a volume in the level, you can resize or reposition it. For more information, see Transforming Actors. Representing volumes visually. Volumes don't have a default visual representation when placed into a level. In other words, a volume actor will be completely invisible at runtime when your game runs. If you want the player to know that volume is there, you must add a visual representation to it. For example, a pain-causing volume causes damage to anything inside the volume. You can use it to mark an area that you want the player to avoid, like poison, lava, or other environmental hazard. What? This water here is weird. This water heater is weird. Noisy boy. Noisy Boise, Idaho. Nebraska. Everyone dies in Utah. If you paste a pain-causing volume into a level, but don't want to add any visual representation to it, the player won't see at runtime. Won't see it at runtime. It. This it. What is it? This it. What is it? You want it all, but you can't have it. Yeah, it's in your face, but you can't grab it. Yeah. In editor in game Pi. In this case, the player will not know to avoid the volume or understand why they take damage when they enter it. You should provide a hint to the player that explains the pain causing volume. In editor in game Pi. In this case, the fire particle effect provides a visual explanation of why the area is dangerous, while the pain causing volume supports the visuals with the gameplay effect of decreasing the player's health during exposure to the fire. You can combine the pain causing volume and the particle effect into a single actor to be able to move them and duplicate them easily. Volume types in Unreal Engine. This section describes some of the commonly used types of volumes in Unreal Engine. Note that this isn't an exhaustive list. Specialized volumes are described in detail in the documentation for their respective areas. Collision and overlap volumes, blocking volume. You can use blocking volumes instead of collision surfaces on static meshes, particularly in the case of walls and structures. This can cause scenes to operate more predictably since physical objects won't interact with small details like bumps in the floor and walls. It can also improve performance by reducing the cost of physics simulation. For more information, see collision documentation. Camera blocking volume. Camera blocking volumes have pre-configured collision settings that block cameras and ignore everything else. They are intended to define invisible barriers that keep the camera out of unwanted locations. For example, in a third-person game, the walls of the play area might have decorative coverings, like leafy vines. In this case, you can place a thin camera blocking volume against the wall so that the camera doesn't bump into the vines or go behind the leaves, leaving it to slide smoothly and provide an unobstructed view of the player action. Kill Z volume. Use a kill Z volume to prevent objects from going out of bounds in certain types of games, such as falling off a cliff or into a pit in a platformer game, or leaving a spaceship without a suit in a science fiction setting. Kill. Ow! I bit my tongue. Kill Z calls. Volume calls the fell out of world function on any actor that enters it. Yawn and burp. By default, actors will go through a quick cleanup procedure and then destroy themselves. You can override this behavior for any of your actor types if your game requires something different. For example, if a key or other item that the player is required to collect in order to continue the game falls into a lava pit, your game might want to teleport the item back up to an area the player can reach, rather than destroying it. At least from inform the player that the item was lost and reload the last checkpoint, rather than leaving the game in an unwinnable state. Pain causing volume. Pain causing volumes described above have a set of configurable properties that you can use to specify the type and amount of damage they cause, how often they damage what's inside, whether they cause initial damage. Configure these properties in the volume's details panel. Physics volume. If you want to configure the physical setup that affects characters and other physics objects, use physics volumes. A common use for physics volume is the creation of watery environments where the player needs to swim. The effects of physics volumes are visible and paired with the appropriate visual representation. They're easy for the player to understand. The character movement component class uses the current fields to adjust how their owning character moves through the environment. If your game has custom physics, derive your own child class from a physics volume. Trigger volume. Phone and nothing. Trigger volume can cause events when a player or other object enters or exits them. Use them with the level blueprint to test out events and gameplay scenarios or functionality without the need for additional blueprints. For example, you could place a trigger volume in your level, then create an overlap event for the volume in your level blueprint, which can play a sound, open a door, or start a cinematic scene. Remember to check the collision settings to ensure that the trigger will react to the intended actors with the overlap collision response setting. Graphics and audio volumes. Audio volumes add sound to the area they cover. There are two kinds of audio volumes you can use. Audio volumes, the legacy approach, audio gameplay volumes. Call distance volume. Call distance volumes cause objects to be called, not drawn to the screen, based on that object's distance from the camera and the object's size. This can help optimize your scene by not drawing objects when they are small enough to be considered unimportant. Size is calculated by the bounding box along its longest dimension. Call distance chosen is the one closest to that size. For more information, see designing visuals, rendering and graphics, rendering optimization, visibility, calling, call distance, volume. Hierarchical load volume. Hierarchical load volumes are used by the hierarchical level of detail. H-LOD system to group actors into a single H-LOD cluster. When generating clusters, the Unreal Engine overrides its normal generation process in deference to manually placed volumes. Light mass volumes, many maps. I gotta poop. Damn cookies. I just wanted to make sure they didn't go to waste. That's silly. Gotta turn away anyways. Right in my poop gun. See, I didn't want to get poop back on it. Back on it? I didn't get poop on it ever. Hierarchical LOD volume. Hierarchical LOD volumes are used by the hierarchical level of detail HLOD system to group actors into a single HLOD cluster. When generating clusters, the Unreal Engine overrides its normal generation process in deference to manually placed volumes. Light mass volumes. Many maps have meshes out of the edge of the grid in the editor, but the actual playable area that needs high quality lighting is much smaller Light mass emits photons based on the size of the level. So those background meshes will greatly increase the number of photons that need to be emitted, and lighting build times will increase. The light mass importance volume controls the area that light mass emits photons in, allowing you to concentrate it only on the area that needs detailed indirect lighting. Areas outside the importance volume get only one bounce of indirect lighting at a lower quality. The light mass character indirect detail volume is similar to the light mass importance volume, generates indirect light samples not just at player height above ground, but inside the entire volume. An example of how this type of volume is used would be to place the volume in the elevator shaft, ensuring that indirect lighting will be correct all the way along the shaft, instead of just at the bottom. For more information, see Light Mass Basics. Mesh merged culling volume. Mesh merged culling volumes mark the mesh objects they contain so that these objects will be combined into a single mesh. This can improve performance by making a collection of small meshes in a contained area all called together as one mesh, or by causing H-law generation to more optimally reduce geometry. For more information, see merging actors. Post-process volume. Post-process volume can override post-process settings applied to the camera inside the volume. You can use it to implement different kinds of visuals in different areas of your level. For example, you may want a different depth of field for indoor and outdoor areas, or different degrees of bloom, depending on localized weather effects like fog. For more information and a list of effects you can use, see post-process effects. Pre-computed visibility volume, and why I wanted routine. Pre-computed visibility volumes are used primarily for performance optimization. These volumes store the visibility of actors for their location in the world. Only place these in areas that the player can access. For more information, see post-process effects. Pre-computed visibility override volume. Use pre-computed visibility override volumes to manually override the visibility of actors for their location in the world if the auto-generated result of a pre-computed visibility volume needs to be adjusted. These are also used for performance optimization and should only be placed in areas the player can access. For more information, see visibility and occlusion culling. Level and AI volumes. Level streaming volumes. Level streaming volumes are used to aid in the level streaming process. They provide a simple way to encapsulate a level as well as control when it streams in and out of memory based on when a player enters or exits the volume. Nav mesh bounds volume. Nav mesh calculates navigation paths throughout the areas of a level. Nav mesh bounds volume are used to control where nav meshes will be built in a level. Within the volume, a nav mesh is constructed on all surfaces with an appropriate angle to be walked upon. You may overlap as many of these as you need to generate the desired nav mesh. Use the nav mesh bounds volume. Create one or more volumes that enclose the navigable areas of your level. Nav mesh will be built automatically. You can press P at any time in the viewport to visualize the nav mesh. Content examples sample project demonstrates how to implement a nav mesh into your level. Next, pain causing volume actor. Pain causing volume actor. Volume reference details. In addition to the properties that can be assigned from a physics volume, the pain-causing volume also has its own set of specific properties outlined below. Property. Description. Pain-causing. Whether the volume currently causes damage or not. Damage per second. Damage done per second to the actors in the volume when pain causing is enabled. Damage type. This determines the type of damage done to the actor. Pain interval. This is the amount of time in seconds between applied damage when pain causing is enabled. Entry pain determines whether or not damage will be applied immediately upon entering the volume. Assuming the pain causing is enabled, the damage is in addition to the recurring damage applied based on the pain interval. Detail actors. A guide to using the deferred detail actor. Deferred details offer better performance and easier maintenance. Writing at the key buffer instead of recalculating lighting has several benefits. The performance of the many lights gets much more predictable because there is no limit on the light count or type, as the same code bit is used for all of them. Manipulating the screen space mask also allows effects that otherwise would be considered difficult. Egg, wet layer, and decals rendered by rendering a box around the decal affecting area. Adding decals to the level. The easiest way to add decals to a scene is to select an appropriate decal material in the content browser, then right-click inside the viewport and place actor from the context menu. The decal may then be resized and oriented using the transformation tools. Sizing, tiling, and offsetting. Once the decal is created, it can be position oriented using the translation and rotation widgets. Non-uniform scaling widget controls the width, height, and far plane distance of the decal volume. Deferred decal properties. A deferred decal has only a couple of properties. Item description. Material. This holds the material that will be used as a decal. Sort order. This allows the user to set a value to control how multiple decals will sort when stacked. Higher values render on top. Be careful when setting sort values. Setting too many sort values on too many different decals prevents those decals from being sorted via state, which can harm performance.
Material settings. The decal blend mode setting defines how the material properties diffuse, specular, normal opacity are applied to the G buffer. The opacity is used to blend the decal contribution. An efficient decal is manipulating only a few G buffer properties. The cases we currently optimize for are represented by the other modes. dBm diffuse, dBm specular, and dBm emissive, dBm normal. Item description, translucent. This will blend the full material, updating the G buffer, and does not work for baked lighting. Stain. This is a modulate based color. Blend rest, updating the G buffer, and does not work for baked lighting. Normal. This will only blend normal, updating the G buffer, does not work for baked lighting. emissive. This is for additive emissive only. Debuffer, translucent color, normal roughness. This is for non-metal put into debuffer to work for baked lighting as well. This will become DBM, translucent normal, if normal is not hooked up. Debuffer, translucent color. This is for non-metal put into debuffer to work for baked lighting as well. Debuffer, translucent color, normal. This is for non-metal put into a debuffer for work for baked lighting as well. This will become DBM, debuffer color, if normal is not hooked up. Debuffer, translucent color, roughness. This is for non-metal put into debuffer to work for baked lighting as well. Debuffer, translucent, normal. This is for non-metal put into debuffer to work for baked lighting as well. Debuffer, translucent, normal, roughness. This is for non-metal put into debuffer to work for baked lighting as well. And this will become DBM, debuffer, roughness, if normal is not hooked up. Debuffer, translucent, roughness. This is for non-metal put into debuffer to work for baked lighting as well. Volumetric distance function, experimental. So output a single distance, sign distance, opacity depending on light vector. DBM's green space mask is special as it affects a special masking channel which is currently used by SSAO ambient occlusion. Screen space ambient occlusion. This allows the decal to override or fade the contribution in some areas. DBM, diffuse specular emissive, is a mode that affects multiple debuffer channels. Note that the material blend mode also affects how the debuffer values are blended together, so it is possible to multiply the diffuse color. You can use the debuffer view mode to inspect the debuffer values that are stored per pixel. The decal. The decal position is a 3D position in the range of 0 to 1. Texture UV is giving you the X and Y component. It's going to be U and Y, U and V component. It's separate. In case you need the Z component, you can hook the camera vector node, get all 3 vector components. There's 5 vectors. The mesh complexity of the objects affected by decal is not affecting the conformance. Damn conformist. The performance. The decal performance depends on the shader complexity and shader box size on the screen. We can further improve the per decal performance. Ideally, the bounding box of the decal is small to get better per pixel performance. This can be done manually. An automated method is possible, but a good designer can also adjust the placement to improve performance further. The view mode shader complexity, editor UI, view mode shader complexity can be used to see the impact on the pixel shading cost. It uses a pixel shader cost estimate and accumulates where multiple decals overlap. At the moment, the decal masking feature has no effect there. Masked parts should have a small constant cost because of using the stencil hardware feature. The following shows a scene without left and the decals right. Normal rendering top and with the shader complexity enabled bottom. Darker color indicates a higher performance cost in pixels. This information can be used to optimize the right shaders, remove barely visible decals, or place them more efficiently. Current limitations. We currently only support deferred decals and they only work on static objects. Normal blending is currently not wrapping around the object. Strumming is not yet hooked up, so make sure the texture is not streamed. Masking decals, not affecting other objects, is not fully implemented. 2x2 block artifacts fixed. Decals have 2x2 pixels block artifacts on wedges as shown in the screenshot below. This is where the node decal derivative comes in. This node must be used carefully as it has a very big performance impact. It returns the derivatives on the x and y axis of the decal's default texture coordinates necessary for anisotrophic texture filtering, but computed differently than using the hardware's default and DDX DDY nodes. To avoid this 2x2 pixel block artifact, using it fixes the artifacts on the decal that benefits from it. Current limitations. Decal minimap level doesn't support custom UV. You can patch up its output. Guide to placing 3D text and using it to create motion graphics. The high resolution 3D text to your level using the geometry based text 3D actor. Use 3D text objects in any project where you need to show clean, high quality text in the virtual world, such as live broadcasts and virtual sets. You can use the sequence editor to animate your 3D text objects, causing motion graphics directly inside the Unreal editor. Enable the 3D text plugin. To use 3D text, you must first enable the Text 3D plugin. In the main menu bar, select Edit Plugins. From the next Text tab, enable Text 3D. You'll be warned the plugin is in experimental state. Click Yes. Click Restart Now to use the plugin in your project. If you have made changes to your project, a window opens where you can save your work before restarting. Placing 3D text in your level. In the Place Actors panel, select all classes, then Text 3D. Drag and drop the Text 3D actor into your level. In the viewport, select the Text 3D actor to view its parameters in the Details panel. Roboto. Text 3D actor settings. The following options are available in the 3D text section of the Details panel to control the way your 3D text appears. Property description, text. Enter the text used to create 3D text geometry. Shift enter to create a line break. Extrude. Set the depth of the geometry, how thick the letters are from front to back. Bevel. Set the size of the bevel along the edges of the characters. Bevel type. Set the type of edge bevel. Linear for a sharp, flat bevel, or half circle for a rounded edge. Half circle segments. Set the number of segments used to create the curve for the half circle bevel. Front material. Select the material for use for shading the front surface of the letters. Bevel material. Select the material to use for shading the surface of the bevel. Extrude material. Select the material to use for shading the sides of the letters. Back material. Select material to use for shading the back of the letters. Font. Select the true type, TTF, or open type, OTF, font asset you want to use for the letters. For more information about getting fonts into Unreal Engine projects, see importing fonts. Horizontal alignment. Align horizontal text to the left, center, or right with respect to the position of the actor in 3D space. Vertical alignment. Align the text vertically to put the top line, top, bottom, or center of these letters in position of the actor. in 3D space. Kerning. Set additional space between each character. Line spacing. Set additional space between each line. Word spacing. Set additional space between each word. Max width. Set the maximum width of the text. Max height. Set the maximum height of the text. Scale proportionally. Locks the height and width of the letters to their current ratio. Enabled, any change to either the height or width of the letters applies to both. Animating letter by letter. You can interpolate the 3D translation, rotation, and scaling of the letters in a text 3D actor between configurable starting and ending values. You can set the order in which the animations progress across the letters in the text, left to right, right to left, and from the middle letters out, from the outer letters in, and then how each letter's animation overlaps with its neighbors. In combination with the sequencer tool, this allows you to design dynamic motion graphics that apply animations letter by letter. For example, the following video shows how to apply transforms to the location, scale, and rotation of the letters in a text 3D actor, then the effect of using a level sequence to animate the transforms over time. Letter by letter animation in text 3D actor is controlled by a text 3D character transform component. You'll need to add one of these components to your actor and set up its values. Set up letter by letter animation. Select your text 3D actor in the viewport or the world outliner. In the details panel, add a component and select text 3D character transform. Select the new text 3D character transform at the top of the details panel to access its settings. I don't know why I'm going to say panel again. Enable the location, rotation, and or scale transforms and adjust their settings to produce the animation effect you want. See the table below for description of each setting. As you adjust the settings for the location, rotation, or scale transforms, you can drag the progress value back and forth between 0 and 100 to preview the effect. Typically, you'll want to use level sequence to play back the animation effect you've designed over time. This will usually involve adding your text 3D actor to a level sequence, creating new tracks for the progress setting, then creating keyframes on those tracks that make the values change between 0 and 100 over time. For example, the details on creating a level sequence and working on sequencer editor. See sequencer documentation. Text 3D character transform settings. The text 3D character transform component exposes the following settings in 3D location, rotation, and scale over your text. You can control the three types of transform separately. Setting description enabled determines whether text 3D character transform component updates the location, rotation, or scale of the letters based on the values in this section. Enabling this option adds some extra calculations for the CPU to carry out. Typically, you should only enable this setting for types of transforms that you actually need to animate. Progress determines the overall progression of the text animation between the begin and end states. At 0, location, rotation, and scale of the text is at its begin state. At 100, at 100, location, rotation, or scale of the text is at its end state. Values in between interpolate in location, rotation, or scale, proportionally in between the begin and end states. If you create a level sequence to animate letter by letter transforms over time, this is typically the setting that you will want to animate in your level sequence. Order determines the direction in which the animation progresses across the letters in your text. Normal. The animation begins with the leftmost letter and progresses to the right. From center, the animation begins with the letters in the center of the text and progresses outward in both directions. To center, the animation begins with the outermost letters of the text and progresses inward toward the letters in the middle. Opposite, the animation begins with the rightmost letter and progresses to the left. Range determines how much overlap there is between adjacent letters. At 0, each letter completes its transformation from begin state to the end state before the next letter begins its transform. At 100, all letters begin and end their transformations at the same time. Values in between create a partial overlap between each successive pair of letters. Begin sets desired initial state for rotation or scale of the letters. All axis values are expressed in the local space of the text 3D actor. For location, the begin position of each letter is always determined by the position of the text 3D actor in the label. End or distance sets the desired end state for the location, rotation, or scale of the letters. Target point actors. Guide to creating and using target actors. When creating worlds for games, you sometimes need to apply the ability to place and spawn items in the world for players to interact with. Target point actors do just this. They give you a generic point in the world that you can spawn items from. If you are familiar with other 3D applications like 3ds Max or Maya or Blender, target point actors are very similar to dummy actors that you find in those programs. Placing target point actors. Target point actors can be found in modes panel under all classes category. To add one to the world, simply select it from the modes panel and then drag it into the world. Using target points. Target point actors can be used for all kinds of things inside Unreal Engine 4 or 5. Here is a list of some of the things that you can use target point actors for. Look at targets for cameras during cinematic sequences. Path points for AI agents. Spawn point for VFX. Spawn points for items like health and item pickups. Visual cue for where an item is placed. It should be placed in the world. Here's an example showing how a target point actor was used as a blueprint to serve as a spawn point. Alright. That was a car. Is this? I don't know. That's right. Playing and simulating, playtesting and simulating your game inside the Unreal Editor. You can instantly preview your game inside Unreal Engine at any time without needing to build it into a standalone application first. This can help you quickly iterate on gameplay and asset tweaks and see how your game changes as a result. There are two ways to preview your game in Unreal Engine: Play in Editor, PI, which you can access from the Play button on the main toolbar; Simulate in Editor, SI, which you can access from the Play drop-down menu or by using the Alt-S on Windows keyboard shortcut or Option-S on macOS. The key difference between playing and simulating in the editor is that playing will always start the game at the player's start location and give you control of the dummy player character. Simulating doesn't move the camera and doesn't spawn the player character. You can toggle between play and editor and simulate in editor sessions as needed. For this tutorial, You have created a new project using the Blueprint third-person template with starter content enabled. If you have not created a project based off template before or are not sure how to enable starter content, refer to the Creating a New Project page to learn how to do this. Play in Editor path. This section will show you how you can use Play in Editor to play your game. With the Blueprint third person template project open, from the main toolbar, click the play button. After you click the play button, this game should start and you should see the character in the level editor toolbar viewport. You will also see the text clicked for mouse control flash briefly in the upper left corner of the level viewport. When playing inside the level viewport, you must click inside the viewport to assign mouse control to the playable character. Click or right click in the level editor viewport. You will see the text Shift F1 for mouse cursor appear in the upper left corner of the level editor viewport. If you want to give mouse control back to the editor itself, press Shift F1 Windows or Shift Fn function plus F1. Mac OS. Well, that's irrelevant. Shift F1. It's wondering what Fn was. It's like FM. Man. When a game is running, you can use the WSD keys for movement, spacebar to jump, and mouse movement to move the camera. During the play session, the main toolbar will change to provide additional controls. Left to right, the controls are pause the game, frame skip, this will be grayed out and unavailable while your game is running in this mode. Stop, ends the play session. Eject releases control of the playable character, switches to mouse cursor controls. You can click inside the level and use a mouse to move around, or you can use editor to make changes to your level. While the game is still running in pilot mode, press Shift F1 to unlock the mouse cursor from the level viewport, then click pause to pause the game. You will notice that the first two buttons on the main toolbar look slightly different. The play button has been replaced with the resume button. Clicking the resume button will resume the game simulation inside the level viewport. The frame skip button is now available. Clicking it will advance the gameplay by one frame, and you can see this easily if you have animated objects such as particle emitters. The stop and eject buttons have the same functionality as described in step 3 above. While the game is paused, click the eject button on the main toolbar. Left click the text in the level viewport to select it. Then, in the detail panel, change its text value to something else. Press enter to confirm the new text. Your changes will immediately appear in the level viewport. From the main toolbar, click the possesses button, then click the resume button. Note that the text in the level has changed from its default value. This method is useful for changing and testing different values for the actors in your level during gameplay. Changes you make to actors in the level using this method are not saved by default. To learn how to keep these changes, follow the steps below. Press Shift F1 to regain mouse control. Then from the main toolbar, click the eject button. With the game still running in the level viewport, right-click the text actor. Then from the pop-up menu, select Keep Simulation Changes. Alternatively, left-click the text editor to select it, then press K on your keyboard. 10. Press Escape to stop the play session. Note that your changes have been saved. Play modes. When you start a Pi session, you can select from different play modes. This section describes what they are and how to access them. From the main toolbar, click the vertical ellipsis button. This will open the Play Options menu. Choose from one of the following options. Selected viewport launches the game inside the currently selected viewport. Mobile Preview ES 3.1 Pi launches the game in a standalone version of the editor and provides additional tools used to mimic devices as closely as possible. New Editor Window Pi launches the game within the editor, however, it creates a new standalone window, leaving the level viewport the same. VR Preview launches a preview of the game on a connected VR device. Standalone Game launches the game in a standalone version outside of the editor. Default setting is selected viewport. Pi Console. Pi Console is an in-game console where you can enter commands to display performance data and enable and disable Unreal Engine features and much more. To open the Pi Console, press tilde key while playing the game in Pi mode. Press the tilde key again to expand the console. Then press tilde a third time to close it. The Pi console behaves the same as Unreal Engine's main console. When you start typing, it automatically tries to complete the console command you're trying to enter. A great use case for the Pi console is to profile a project's performance. To learn more, refer to the Start Commands page. Simulate an editor. In this section, you will take a look at Simulate an Editor and how to simulate your game. With the project open inside the content browser, open the Start Content Props folder. Click and drag Material Sphere into the level just above the stairs. To find Material Sphere prop quickly, use search box inside the content browser. Click the sphere to select it. Then click the arrows of the translation widget to move the sphere up above the stairs, as shown in the screenshot below. In the details panel for the sphere, scroll down to the physics section and enable the simulate physics checkbox. When you start to simulate or play the sphere, the sphere now has physics and should fall to the ground. Press Alt S, Windows or to simulate an editor. Note that although there is no playable player character in the level, the game starts and the sphere falls to the ground. Escape to stop the simulation. Note that the main toolbar now displays the Simulate button instead of the Play button. Just like vomit. This button will always reflect the most recently selected player simulated mode that ran for this project. Click the Simulate button again and then immediately click the Pause button. From the main toolbar, click the Frame Advance button to step through the simulation. Every time you click the button, the sphere should move further down. Running the engine as a game editor, including how to launch specific map and useful in-game commands. Select an option from the drop-down to see content relevant to it. The instructions on this page are for running the engine, projects compiled in the development build configuration. You can substitute the Unreal Engine editor.exe Unreal Engine.exe that you need for opening projects built in other configurations. For more information on the binary name convention, that can be found on the Building in Unreal Engine page. Running the editor. The process of running the editor requires passing the name of the project to run as an argument to the executable. You can add the debug switch to force the executable to launch the debug version of the modules for your project, which contain all the debugging symbols. This is necessary even when debugging through Visual Studio with the configuration set to debug, because the main executable is always compiled in the relevant configuration. Of course, you must first compile your modules using the debug configuration so that they exist for the executable to load. Running the editor from the command line. From the command prompt, navigate to your launcher install version number engine binaries Win64 directory. Run the Unreal Engine editor.exe, passing it the path to your project. Running the editor from the executable. Navigate to your launcher install version number engine binaries Win64 directory. Right click on the Unreal Engine editor.exe executable and choose the shortcut. Choose create shortcut. Rename the shortcut to something like myprojecteditor.exe, as this reflects that this shortcut runs the My Project Game Editor. Right click on the newly created shortcut and choose Properties. Add the name of the game to run as an agreement at the end of the target property. Press OK to save the changes. Double click the shortcut to launch the editor. Source control. This document overviews, setting up the source control. I gotta drink water. My throat dries up fast. This document overviews the source and control features. The Unreal Engine editor has built-in support for source control packages. Source control is used to manage changes over time to code and data. Enables teams to coordinate their game development efforts. Perforce and SVN are supported by default. Activating source control. You can activate source control in one of two ways. The level editor's preferences window in the content browser. Activating source control via editor preferences. You can activate source control via the editor preferences window. Editor preferences, loading and saving. Item description, automatically check out an asset modification. When checked, this will automatically check out any asset that has been modified. Being modified. Prompt for checkout on package modification. When checked, a prompt will appear when you make changes to a source control package. If you would like to check out that package, add new files when modified. This will add new files into source control when they are modified. Use global settings. Use global source control login settings rather than per project. Changing this will require you to log in again. Tool for different texts specifies the file path to the tool to be used for differing text files. Activating source control via the context browser. You can also activate source control in the content browser. To do so, right-click any asset or folder. At the bottom of the context menu, Source Control section, click Connect to Source Control. This will open a login screen where you can select your source control system and enter the appropriate settings and other information. Enter the appropriate information and click Accept Settings. After source control is activated, the display of the assets in the content browser will change to reflect their source control status. And some source control options will be included on the right-click context menu. Status icons. The content browser will display current icons in the upper right corner of the assets to give the source control status. Below are the available icons and their meanings. Checked out by you. Checked out by another user. Marked for add. Not in the depot. No version of the file exists in source control. Source control actions. While source control is active, the following context menu will be available when you right-click on an asset. Item description checkout. Checks out locks the asset for editing. This prevents other users from editing the asset at the same time. Refresh. Refreshes the source control status of the asset. History. Gives a revision history list of the selected asset, allowing you to see previous edits. Diff against depot. This allows you to check the asset against the versions currently stored in the source control depot. Checking out and checking in. To check out an asset for editing, simply right-click it and choose Checkout. When checking the asset back in, adhere to the following protocol. Right-click the asset and choose Check In. Dialog will appear with the required change list description for the check-in. Enter a description which will be added to the asset's revision history. Click OK when finished. Change the description is required, so the OK button will not be enabled until a description is entered. Content Hot Reloading. Content Hot Reloading is a new feature that the in-editor source control uses to reload content automatically when the content has been modified by source control operations. Currently, automatic reloading only works when performing source control operations via the in-editor source control integration. And any external changes won't trigger reload. We intend to remove this requirement in a later engine version, so that external changes will also trigger hot reloads. Content hot reloading also provides the ability to reload an asset from its last saved state or on command. This can be done by right-clicking the asset in the content browser and selecting the reload option under the asset actions group. This can be extremely useful if you have unsaved changes to an asset that you wish to discard in order to revert back to the on-disk version. This feature currently carries the requirement that you have source control active for your project. Deactivating source control. You may find that you want to deactivate source control after activating it. Only use this option if you are absolutely certain that you do not want to use source control. Deactivating source control will put your content out of sync with your source control system, and make it impossible to check in changes. To deactivate source control, in the upper left corner of the level editor, click the green double arrow icon. This brings out the source control login screen. Click the Run Without Source Control button. The green icon in the level editor to Windows hits the red circle with a slash to indicate that the source control is not being used. Alright. So with that, I bid you adieu. Until next time, which will be tomorrow. I'm going to read the Working with Content section. I'll even click on it right now. Oh wow, that'd be a short video. Cool. Anyways, love you. Love you lots.